Welcome back guys to our channel Science 369. Today we are going to study the topic from class 10th Science 1 paper and the chapter 1, which is gravitation. Gravitation is a very much familiar phenomenon to all of us. Because of gravitation, everything falls down towards the Earth's surface and we know it. But what is the reason behind it and what are the laws related to it that we will study in this chapter? Okay. For this, the total chapter is divided into 10 topics that I am going to tell you, and each topic I am going to explain properly. Okay. Yes, so let us continue here. Here are the topics from the chapter gravitation shown here. Total there are 10 topics. First one is the gravitation. Second is force, motion, circular motion and centripetal force. Third one is Kepler's laws. Fourth is Newton's universal law of gravitation. Fifth is uniform circular motion and magnitude of centripetal force. Sixth is Earth's gravitational force. Seventh is Earth's gravitational acceleration and variation in the value of g. Eighth is mass and weight. Ninth is free fall, and tenth is gravitational potential energy and escape velocity. Now we will see each topic in details. So let us see. The first topic, gravitation. Now what is gravitation? This is the phenomenon which was discovered by Sir Isaac Newton, which we all know. Newton concluded that from his famous apple story. We all know the famous apple story related with the Newton, Sir Isaac Newton. Sir Isaac Newton was sitting under a tree in a garden and an apple falls down, and Newton thought that why the apple falls down, why it didn't go up. And from here the study of gravitation started, and from his experiment Newton concluded that Earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the Earth. Thus, any object on Earth falls towards the Earth in a vertically downward direction. Newton also thought that the force of gravitation can also act on the objects which are much farther away from the Earth, like Moon and Sun. Gravitational force is also acting on the objects like Moon, Sun, which are not falling towards the Earth's surface but which are revolving around the Earth, or Earth is revolving around the Sun. Second topic is force, motion, circular motion and centripetal force. Here we have to study. We know what is force. We have studied in the previous standard, that is in the 9th standard, what is force. Now there is a basic relationship between force and motion. Because of force, there are many changes in the motion. There are basically three effects of force on the motion. Force can change the speed of object, that is, it can increase the speed or decrease the speed of the object. Second is force can change the direction of motion of object and thus can change the velocity of the object. And force can also accelerate or decelerate the object. That means there will be increase in the velocity and here there is acceleration, or there may be decrease in the velocity and here there will be the deceleration in the object, and it is all because of the force. Now, by learning this effect of force on motion, we can study what is circular motion. Circular motion is the motion of an object along the circular path is called as circular motion. Whenever any object is moving around any circular path, then we can say that the motion of that object is a circular motion. We can see some example for this. The first one is the motion of the stone tied to the string, motion of the coin on the rotating disc, motion of the moon around the earth, motion of all the planets around the sun, motion of electrons around the nucleus in an atom. These are all the examples of circular motion. In each case, the object is revolving in a circular path. Let us see the next point. Now see, in all these examples, objects are moving in a circular path, so these are all circular motion. And in all these circular motion, a force is acting on the object called as centripetal force. So for each circular motion, centripetal force is required, and that centripetal force is defined as the force acting on any object moving along a circle and directed towards the center, called as centripetal force. Now for each example which we have seen for the circular motion, for each example there is a centripetal force acting on that object. In case of the stone tied to the string, this force is supplied. This force means centripetal force is supplied by the tension in the string, which is applied by the person who holds it. In the second case, coin moving on the rotating disc. In In this case, the centripetal force is applied by the friction between the surface of coin and the disc. In case of moon revolving around the earth, guys, so let us continue from the third topic, which is Kepler's laws. Now these laws gives us the information about the motion of the planets around the sun. Motion of planets around the sun are governed by certain laws, and these are discovered by Johannes Kepler. These are also called as Kepler's laws of planetary motion. Now let us see first law, Kepler's first law. This law states that the orbit of the planet is an ellipse with the sun at one of its foci. Second law is the line joining the planet and the sun sweeps equal areas in equal interval of time. Now these two laws can be explained by this diagram. In this diagram there is a star, which is the sun here, and this body is the planet, and which is revolving around the sun in an orbit which is elliptical orbit. So this is the first law, that is orbit of the planet is an ellipse with the sun at one of its foci. Now the second law, for the second law we have to join the planet with the sun by the line, and it was said that the line is sweeping the equal area in equal time. For this, these are the lines joined from the star to the planets at 4 different positions and 2 different motions, that is motion A from here to here and motion B which is from here to here. Now in both these motions, object is moving from one position to the another position and sweeping area A in case of first motion, and in the second case object is again moving from one position to another position and sweeping the area B shown here for that particular motion. Now as per this law, if the time required for this motion and this motion is same, then the area swept by this line will be same. I am again repeating, if the time for this motion and this motion is same, then the area swept in motion A and in motion B will also be same. Conversely, we can also say that if area swept by this line for both this motion is same, then the time required for the two motions, that is for motion A and motion B, will also be same. That is Kepler's second law of motion. Then the third law, the square of the period of the revolution of the planet around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Thus, if r is the average distance of the planet from the sun and t is the period of revolution, that is time required for one complete revolution. Again we can see in the previous diagram, this is the star, this is the planet. If the planet performs one complete revolution, then whatever the time required for that motion is called as the periodic time of the planetary motion, which is denoted by capital T, which is shown here. So small r is the average distance of the planet from the sun and capital T is the period of revolution. Then by this law, t square is directly proportional to r cube. So t square upon r cube is equal to constant, and that constant can be taken as k. So this is the Kepler's third law. Next point is universal law of